In fact, I started this in at IIT Kharagpur way back in 2013 when I joined, and then I actually moved from IIT Kharagpur to IIT Tirupati in 2017. We continued on, and today we are, as I just mentioned to you, we are at the cusp of moving from linear to semicircular with this very new technology. I would say new because it's not very much explored as far as microstructural or even for that matter, high strength systems. Okay. So just to start off with what we envision as the roadmap, and this is our research cluster. So we have close to 27 students in our research group, approximately 12 PhD students, and more than a dozen BTech, MTech, and MS students working with us, also a couple of postdocs. It's a large group. We call ours materials for sustainability, asset management, and performance monitoring of smart infrastructure. Okay, we call ourselves MapSmart. And you can please visit this website whenever you're free. We have a very dedicated lab for pavement research. Again, it's not just pavement. Okay, it's more of the materials, sustainability, and also we do a lot of work on asset management. If you talk to the Government of India Ministry of Road Transport, they say that it's not just about building, it's also about saving our assets. And that is something that we have to really do, not just pavements, but also bridges, buildings, and so forth. Right? And this is a picture of what our lab looks like. It's a very compact lab today, but we are building at least 50,000 square feet. I'm not mincing my words. It's close to one plus acre of pavement lab coming up, as you see here. And I explain this to you. It's again a circular track. It's not a circular economy, but it's a circular track that we are building on campus. Again, we have done a lot of work on asphalt rubber, recycling of rubber granules. So I'll explain that first. Okay, and then the other thing is a pervious concrete block. So I just mentioned you one of the other systems that we have been working on. Okay, so we do a lot of fundamental research catering to binder conservation, rheology, and so forth, and then moving on to the aggregates, the rocks, and then to the mixtures. So if you look at the pavements, we actually have the mixtures. Right? It's not just the binder or the aggregates. Yeah? But if you look at the older pavement systems that we had about 50, 60 years ago, they were all made up of aggregates that were not that strong, and they were basically virgin materials taken basically from the quarries. So they were all natural resources that we have been depleting over the last several decades. Okay, so what we have done over the years is to start manufacturing our own aggregates. That's where the circular economy comes into picture. And then we have also started building mixtures that are conglomerates, composite structures. I'll explain that to you. You can explain something. So we also do a lot of state-of-the-art advanced research. Okay, we have state-of-the-art equipment worth more than 4 crores. We are also building another 20 crore worth of lab, which will cover not just this, but also many other accelerated testing facilities. So these are the projects that we have right now. Currently, we are running close to about 17, 18 crore worth of projects, all the way starting from the national highways. That is a flagship project where we are coming up with new performance metrics for the national highways, and also that could be, it will actually ramify for the state highways and other district roads. The other thing that we have been very actively working on is the collaborative project transfer of technology from India to other countries. For example, the University of Sharjah, which is based in the UAE, United Arab Emirates, they have actually asked the technology transfer from India. So we have been transferring technology of our Pervious company, and Professor Dubey is very much aware. In fact, even Ravi Shankar is. One of the speakers today who will be speaking in the afternoon was actually working on the project on Pervious concrete development, Dr. Anush. He was one of our students at IIT Kharagpur, now a faculty at Bhubaneswar. Yeah, so we started this show back in 2013, and we've continued on at IIT Tirupati. And I'll share more details about what we have done from linear to semi. Okay, the other thing I was mentioning, the asset management that actually completes the overall picture of pavement materials, pavement construction, pavement evaluation, assessment, and then the management system. So that's a complete circle of what we do with technology. And we have been very actively involved with the state government, possibly one of the IITs, very first IITs in the country where there is an academic roadway agency model that we developed. And very successful. We have got a lot of data from the state government of AP, and we've been fortunate to get more than 1.4 million data points. And we have continued on our association with them and also transferred the technology to several others. Okay, the other thing that we have been doing with Petroleum Conservation Research Association, Government of India, is now the high-end technology project where we are developing our new generation accelerator, where we are going to include more than double the recycled rubber into the pavement system. That's where our circular economy actually is. And I'll explain that to you. And very, very importantly, we are working with CSR. So it's a corporate social responsibility project with RV Associates, where we are coming up with LCA of pavements. So we are possibly one of the first few groups to work on LCA in India, okay, on the pavement systems. I mean, a lot of groups have worked on plastic waste and then bottles, or maybe the solid waste and so forth. In fact, so the way is an expert in LCA. I'm no expert, but I'm just trying to tell you that we have started to work on LCA as well over the last 5 years. We have been very successful in getting excellent results, not just with the licensed software, but also we have developed our own software tools. I'll explain that to you. Okay, and the other thing that is a flagship Ministry of Road Transport and Highways project is the development of the national facility, where we are coming up with actual trucks running along a circular track, and we are accelerating the performance of these pavement systems. It's a 100-meter test track. Okay, we have both circular and a linear track that's being built on campus IIT Tirupati. So if you come to IIT Tirupati, let's say by January 2024, our facility will be ready. It will also be inaugurated by the ministry. So it's something like this. So where we have a circular track and we have two trucks running continuously. And what we're trying to do here is we are accelerating the performance. So if you want to get the performance of a pavement system for 10 years, you can get that done within 3 months. So that is something that is a flagship ministry project, and we will be mentoring many other zones or institutions in the coming future, should this be very successful. It's a first of its kind facility in the world, I should say, because there are no facilities in the world where they're running actual trucks. So they're all mostly double tire, dual tire assembly, or it could be a gear assembly that's running to understand the accelerated performance. But what we are doing here is to have actual trucks. We have a tie-up with Ashok Leyland. It's one of the pioneers in automotive industry, where they actually told us that they'll give us 2 trucks to work with. So it's a BS4 truck. So it's a conglomeration of 2 important departments. Okay, in the infrastructure area, one is a civil and environmental engineering, and the other is a mechanical engineering. So we are running this project. It's a very, very important project. Okay, and where we are applying this facility, it's again road industry, construction infrastructure, automobile. Again, circular economy comes into picture, where rubber industry is also playing a major role, not just with the pavement system, but also with the vehicular tires. So if you wish to change your tires on the truck and want to test these, you should be able to do that. Okay, so a lot of government and concessionaires are all there as part of the thing. And again, it's a fully made in India. Okay, Atmanirbhar Bharat. That's something that we have to do, and we are also in discussion with Ministry of Environment, Forest and Climate Change. That is something related to circular economy, where we are coming up with standards and guidelines that will be very clearly touching the SDG, Sustainable Development. Right, so as part of this, we'll also be doing a lot of things. Okay, now coming to the circular economy as such, we talk about the pavement design. What we do is, again, discretize. One is the material aspect, okay, which we are very familiar. Okay, we are able to do this for the last 100 years, and we have been very, very successful, including in India, where we are able to capture the material properties, the strength parameters, the deflection, and so forth, including in the field. But one of the things that we haven't taken care is the uncertainty. When I say uncertainty, we are not touching the dynamics of the vehicle. So one of our students, I should say, at least 3 of our students have been working on this uncertainty. Okay, and then including that into the vehicle type. So if you look at the current design standards, we are looking at one vehicle type across the world. Okay, it could be 8-ton vehicle in India, 8-ton across somewhere else, but it's just one vehicle type. What we are trying to do here is to integrate several standards. Then we have different vehicle types, material uncertainties, and then again come back to predict our pavement performance. That is where we are today in terms of mechanical design. And coming to the emission, so if you talk about the Conference of Parties, the COP, that's going to take place in Dubai very soon. And in fact, IIT Tirupati also has taken initiative conducting a workshop very soon. We'll be doing that on climate change. Explain that later whenever time comes. Okay, so what we have to do today is we have this pavement side, that's the harder side. Then there is this traffic emissions coming from the vehicle exhaust. We have to integrate these two. Today we don't have that. Why we should do this? Because we need to have three important facets coming out of this and understand the entirety of this. One, coming from the environment, two, economy, and then the human. So we have to touch upon these three very much, and that only will help us understand the damage that is being caused to the transportation system. And that's where I think this decarbonization comes into picture when we integrate both of these hard side and the soft side. So we are capable of this separately and this separately, but we have not integrated these. So one of the things that we think, okay, and this is our group, Map Smart group, that very clearly what we have thought about for the next 50 years. I've also presented this as one of the visions for the TIFAC and DST, is that we are looking at the cost effect model, but we are not actually looking at the circular economy model. We're looking at source problems, right? We're looking at the development, operation, and maintenance discretized. So they're all separate now, separate entities. And that actually, it's true that it is actually costing burden on the resources. For example, if you go to a quarry, we are pulling a lot of natural resources. They're all the virgin aggregates, virgin binder that we are using. We are not able to recycle it to the extent that we would like to. For example, if you say, I would like to use solid waste in roads. Are we really capable of doing that today? I would say no, not fully. Okay? C&D waste, construction demolition waste coming from the buildings, we are not able to completely utilize. If we talk about rubber, we have been successful in utilizing approximately 15,000 tires per lane kilometer. That is good, okay, because we are able to utilize the end of life materials, and that goes back to the building of a new system. So it's an old material being used to create a new system. That is circular economy. That's actually good. Now, one of the other things that people have tried, and we have a new project coming from the DRDL very soon. I'll explain that possibly in the next few sessions whenever we are going to meet again, is to use the composite waste coming from the aircraft industry. Okay, so we have DRDL producing turbines and so forth, right? Engines and the machinery there from the DRDL ASL. What we told them and we convinced them is, give us these composite wastes which actually have carbon fiber and glass. They're simply dumping it in the landfill and not being used. And trust me, approximately more than 40 tons of composite waste is now dumped in landfills across the country. Can we not use this in roads? This is something that we tried with one of our MTech students. We were very successful, and I'll explain that also later on. So what we are trying to do now is not the cost relationship, but come up with a need that we need to come up with several strategies, not just maybe several, to reduce carbon footprint through NCA, NCCA, and so forth. Now, where we are today, we are trying to conserve resources by utilizing end-of-life materials, waste. It could also include e-waste, by okay? We haven't come there yet, but I think in the future, maybe. Now, life cycle carbon reduction, this is something that we are working on. I'll explain to you what we have done. Again, there is no single definition. So Dubey will be much better than me in explaining these concepts to you, waste to wealth and circular economy. But this is something that even the ministry wants us to do. Don't just dump your aggregates after they have been used 15, 20, 30 years. Reuse it. So we call that recycled concrete aggregates, recycled asphalt pavements. Okay, so now if you talk about where we are with circular economy, I don't think we have touched upon these that we show you here in this. Reduce, reuse, recycle, rethink, remanufacture, recover, responsibility, repair. There are many more, okay? But there are more than 12 or 13 R's, and what we envision, and this is my vision for the next 50 years, and we move from linear to semicircular and then transform ourselves from semicircular to fully circular. And how is that? You see here, they're all very simple. It's a simple concept I'm saying because it's actually easily understood by any layman. There's nothing that is esoteric in this case. One is the recover and recycle. That's where we are today. Okay? We are very successful in this case. That is linear, where we are able to recover the materials that have been used over the last 20, 25 years, 30 years, maybe 40 years. Okay, we are able to recycle that, which also includes now the end of life tires, end of life waste. For example, I told you composite waste or plastic. Okay, they're all being used in roads. Now, recover and recycle is what we do today as part of linear economy. Now, some other people might differ with my definition, but based on my literature and also our group, we found that this is still part of linear. Someone can correct me later on. Then, what we are trying to do today, and we are, I think, at the cusp of doing this full-fledged. When I say full-fledged, we are able to remanufacture the recycled products and recovered products into sustainable materials. Okay, and that is where that green material concept has come into picture, and we are able to target LCA very clearly. So that's where we have this resourceful extension of lifespan. So today, if someone says, okay, I'm going to use older materials into building new structures, new pavements, people will get skeptical. Oh, it will not be that strong, long lasting. But we have actually found that if you recycle rubber, composite waste, plastic, it lasts longer than conventional materials. So we have actually been successful in that, right? So reuse of the materials through remanufacture. That's where we are today. That is semicircular, and I think we have been successful. Now, coming to the rethink and reduce, this is where we have to really touch upon in the next maybe 30 minutes. Okay, so rethinking of how we can integrate. I just showed one slide where we are integrating the materials and the traffic emissions, exhaust, right? So that's where LCCA, the models, the prediction of reliability, for that matter, lab to field correlation, we have done a little bit more work across the world, but we haven't really done much. So this is something holistic. So it has to be an integrated mechanistic design for pavements, integrated mechanistic design for materials, and then we start reducing the emissions. And then the global warming potential, greenhouse gases, costs, energy, and so on. That's where we really need the ministry's support. I think if we can really touch upon with real world problems, we should be able to convince the ministry, not just ministry, several other centralized institutions, including IITs, CSIR labs, NITs, and other institutions, okay, to start thinking of the reduction of the emissions. Now, so this is where we are. Okay, 2 hours for the linear, 2 hours for the semicircular, and 2 hours for the fully circular. And this is where we are with our group, and we have been working on several global sustainable innovation programs, including at Purdue and Arizona State, where I'm a professor at both institutions. Now, something that is as food for thought for several of you who are working in this area. Okay, it's not just about roads. Again, you can see a lot of words that are away from the road. I just thought I'd bring this slide. And again, there is a color coding here. If someone is thinking of what these colors, if you start pondering what these colors actually mean, we are here. Okay, recycling, we are able to think on these lines. So we are, the green things is what we would like to achieve in the next 20, 30 years. Linear is what is all these in black and color. Black color is all linear economy based. Rating system, regulatory mechanism, that is where semicircular, and we need government's help, policy making, okay, environment, socio-economic, and social life cycle stages, right? And then again, asset management, mentioned this in the beginning, we have to save our assets, otherwise we'll be dwindling our resources in the long run. And then integration, and that actually goes back to the technologies and then using of these advanced technologies into coming up with data collection protocols, material prediction, okay, and then product I'm actually a member of this committee. Now I'm chairing this global committee on pavement life cycle. It's a committee that's calling for papers. The papers are due. It's a full-fledged journal owned by Sage, but linked with Transportation Research Board. This is the flagship transportation research forum across India. Okay, where I'm a committee chair. We have first. We still have time for 40 days. So, and we are actually touching upon several ideas, SDGs, and many other areas such as material circularity. Okay, and then discount rates, advancements of standardization of policies, and so forth. Okay, case studies also we are soliciting. So, if you submit a paper on infrastructure, it's not just about pavements again. Bridges, infrastructure, you name it, it's there. So it's also material. So please feel free to visit this or please email me. It's there here, and I'll let you know more. Now coming to the actual aspects, we have 1 hour now, and I'll only take about 35 minutes. Then we can solicit some questions and also go in for long-term discussion. Okay, so first module that I thought I'll share with you on where we stand today with respect to recyclability and moving from actual linear to circular. We are moving towards circular with this product. Okay? And this product has been there at least for now, if not more, about 70 years. Okay, a very tested product across the world. More than 40 countries have used asphalt rubber technology. And what it actually is, it's a blend of asphalt cement. Okay, when we say asphalt cement, in India, we call it bitumen. What you see on roads, that's called blacktopping. Okay, asphalt cement and reclaimed tire rubber. So how much rubber that we use today? Okay, what ASTM, American Society for Testing and Materials International, very clearly states that we should have at least 50% in wheat or have 1 ton of asphalt cement. So 15% of that will be what? 15 tons of rubber could be used with 1 ton of production of AR. So that will translate into a mixture to about 1.6 to 2% when you say 15 to 20% of rubber. That's there in the mixture by volume. So it's about 15,000 tires that we recycle per lane kilometer. Now that's per lane kilometer. If I say, you have seen, a lot of you have used the facility. There are 6 lane roads. Each lane I'm able to use lane kilometer in lengths, 15,000 tires. If you, that is for the 20% rubber. So I'm talking in terms of 20% rubber that I'm using. Let's say I would like to translate this into 40% rubber. Okay, we are going into furthermore using more rubber into the conglomerate. If it is 20% your number of tires that are discarded, not into the land, but reused, remanufactured as asphalt rubber, will be approximately 30,000 tons, right? 15 times to 30,000 times. So if now you see where we stand, today we are saying this material is using approximately 15 to 30% rubber. If you go to any Indian refinery, they will only tell you that they got 8 to 12% rubber, which is still big. Okay? Someone has to mute. Yeah. So today what we do is we have about 8 to 12% rubber in asphalt cement, which is not still bad. Can you hear now?
Yes, sir. Yes, sir.
Okay. I'll just repeat what I'm saying. So we're trying to look at 30,000 tons being recycled into our pavement system, and that's 100% of particles finer than 4.75. If people are civil engineers, you will understand this better. 4.75 millimeter is the benchmark above which we have coarse aggregates, larger size aggregates, below which we have fine aggregates. So we're looking at 100% passing this size and retaining on 2 millimeter sequence. particle size. Okay, and you can see specific gravity of this material is approximately nearly 1.1, 1.2. And that's very close to asphalt cement. That is why they're able to blend well. Okay. And now what we are saying today is if you are able to recycle 20% within asphalt cement, you produce asphalt rubber. And that gives you a super product. Okay, I call it super product because it's being used across all layers as a strong base, and also a wearing course. When I say wearing course, that is what you see on roads. Okay, and it's being used across various climates. It's being used in very hot climates such as Kharagpur. Okay, 80 plus degrees Celsius of pavement temperature, minus 40 degrees Celsius in cold regions, including in Canada, Sweden, Nordic countries, and so forth. And it's also being used as a very thin layer to replenish groundwater. How is that? Because it's a porous mix. You can create a porous mixture with asphalt. Okay? That's being translated again into a very strong structural layer and a function, both. And it's also being used as a composite. You see, a concrete layer is there. On top of that, I'm placing an asphalt. So it's being used in several technologies. And we call this a perpetual pavement system. Why do we call it perpetual? Because there are an umpteen number of benefits coming out of this. Definitely more durable. And we have tested this. There are a few sections. If you go to some of the states in the US, there are sections which have lasted for 35, 40 years. Excellent skid resistance because it offers open texture, okay, larger size aggregates, smooth ride, which is what you want to see. I just mentioned